In this video, let's try to understand how we can make use of a graph. So I'm going to give you two examples where we actually can really make use of the graph. So suppose we are given a question that a rectangle with side parallel to axis vertices, to the axis vertices 3, -2 and -4, 7. Find the area. So let's try to work on this. So what do we have? We have two vertices, 3, -2. So 3, -2 means x-axis 3 and y-axis -2. So this is what it is. Okay, this point is 3, -2, right? And the other one is -4, 7. -4, 7. So -4 is x and 7 is y. So where you will find it somewhere here. So it's going to be here. And we're talking about a rectangle being formed. How will a rectangle be formed? When we will be able to join the vertices, right? So how will we join? So extend that. So these have to be two parallel lines. And then, okay. And then we will join the other side. So this is your length and breadth. So 7 should be somewhere here. And this should be cutting -2 actually. So let -2 be this point. Okay. So this becomes a rectangle. And how do I find out the area of a rectangle? Now, area of any rectangle. Area of a rectangle is basically length into breadth. So you have length and breadth, and area of any rectangle is length into breadth. So length would be no distance formula, nothing required. You don't need to do that much. All you need to do is you need to find this length, guys. So what is this length? This length is clearly y-axis value that you get from here till here, or the gap that you have from here to here. So essentially the y-axis value here, this y-axis value is, the length is 2. The point is -2. So that means it's 2 units out here, right? And here y-axis value is 7. So which would mean that your length is 7 plus 2. I'll repeat myself. This is 2 units. It is -2. The point is -2, but that means from origin, the distance is 2 units. And from origin, the distance up till here, this is 0.7. So 7. Breadth would be the distance from origin here and plus the distance from origin here, which clearly is 3 from that side, from the right side, and it's 4 units from the other side. So 9 and 7. So clearly, graphically itself, I don't need any formula to it. Graphically itself, the area, the required area is 9 into 7, that is 63 units. Okay. So whatever units would be given, that is the graph. That is the area, and we've just figured it out through the graph. Now, next is an interesting question, because here we will learn few things as well, apart from just graph. So, in this question, we have that fx is equal to x squared plus 2, x is greater than 0. Show that f is invertible. First of all, show that f is invertible. And then show graphically that fx and gx are symmetric about y equals to x. So inverse, we are saying that invertible, and inverse is g. G is inverse. That's what the question says. And we need to show graphically that f and g are symmetric about y equals to x. So, well, invertible. So f is invertible means that I need a one-to-one correspondence. So y is equal to fx equals to x square plus 2, which means f dash x is equal to 2x, and x is greater than 0. It's given, it's strictly greater than 0. So this is strictly greater than 0, which means that f is a strictly increasing function. So f is a strictly increasing function implies that f is 1 to 1. And if you remember, the moment a function is 1 to 1, then you can create its inverse. So it can be invertible. It can be made invertible. It can be made invertible. Now, y is equal to x square plus 2. So that implies x is equal to square root of y minus 2 plus minus, but we will ignore minus because x is given to us that it's greater than 0. And that's why we can actually find easily, we can create this inverse. This is because, you can write it down, because x is greater than 0 implies y is greater than 0. So we don't have any issue here. Okay, so we don't have any issue here. So we will ignore the minus sign basically. Okay. Now, what is the range of, to analyze further, what is the range of f? What is the range of f? Now, fx is given to you as x square plus 2, and x is strictly greater than 0. So clearly that implies fx has to be strictly greater than 2. Clearly fx has to be strictly greater than 2. So therefore I can say that the range of this function is 2 to infinity. Range of this function is 2 to infinity. So that means we can define. Why do I need range? So that I can define the inverse properly. So we can define f inverse equals to g from 2 to infinity to whatever. So 2 to, if you take the domain of f inverse as range of f, then you can define an inverse for any one-to-one function. Okay, then you can define an inverse for any one-to-one function. So always remember this. And this can be defined as gx is equal to, we already have figured it out. So it is equal to 2 minus x. And this will be greater than 0. So this will be greater than 0 because x is, your input is more than 2. So this is a valid function. It's a valid function because the input is more than 2. Okay. So remember what we have done here. Domain of f inverse or domain of g is taken as the range of f. And that's how you can define an inverse of a function which is 1 to 1, even if it is not onto as such. Now, the next task that I've given to you, which is the graphical thing, which is you have to show symmetric on graph. How to show symmetric on graph. How to show symmetric on graph. So we have to show symmetric about, x equal to y or y equals to x, whichever way you want to write it. So we have to show symmetric about x equal to y, symmetric about x equal to y. So what we will do graphically. So guys, graphically that means what we will do, we will create the line. So suppose this is y-axis and this is x-axis. Let's create the line x equal to y. X equal to y, of course, is 45-degree line. I hope this is an appropriate one. It's dividing this entire thing into half. So you will be getting all x equal to y. So this is, say, y equals to x. This is y equals to x. Okay, guys. So what do we have here? We have fx and we have gx. We have fx and we have gx. So let's analyze this. What will it look like? What will it look like? Let's analyze this. So you guys, fx is equal to x square plus 2, where x is greater than 0. So f0 plus will be something, it's x square plus 2. So this will be like something 2 plus, a little more than 2. F of 1 will clearly be 3. F of 2 will be 6. Now similarly, if we talk about g here, so gx is square root of x minus 2, where again, here x is greater than 2. That is why this is a valid function, right? So here g2 plus would be something tending towards 0. 0 plus g1 or g3, I would say. G3 would give me 1. G3 would give me 1. And G4 will give me root 2. And G6 will give me square root of 4. So that is 2. Please understand here what I'm trying to tell you. So here, the input 0 plus gives you 2 plus here. Here the input 2 plus gives you 0 plus here. Input 1 gives you 3. Input 3 gives you 1. That's what is your invertible relation. Input 2 gives you 6. Input 6 gives you 2. So that's what is your invertible relation. Okay. So basically what is happening is basically 0 plus has a relation with 2 plus both ways. 1 has a relation with 3 both ways. And 2 has a relation with 6 both ways. So these are just few examples that we've taken. Of course, anything that we would take will, give you the same thing. So this means that functions are symmetric about y equals to x. They're symmetric about y equals to x because you know the invertible relation is such. And if you will graph it, guys, let me take some other color. So suppose this is 2 here and this is 2 here. So what's going to happen is you would notice that, so this is a parabolic thing here, and this will be, because when x is 0, so you are getting something 2 plus, and it will go like this, and this will be, going something again parabolic, sort of like this. So it is a curvaceous thing, so it should not turn out as a straight line, something curvaceous like this. So what you will see that you have mirror images. So symmetric about y equals to x, this means you have mirror images about or around x equal to y. You have mirror images, and that's what means symmetric. around x equal to y.